Eelgrass, if you can imagine just grass outside your house, it's like that, but underwater. It's a nursery habitat. When the organisms are young, they need somewhere to be protected from predators. So they spend a lot of their younger years in the seagrass.
Eelgrass is really important for our coastal ecosystems. The meadow forms that structure, that habitat that everything else relies upon. They need seeds to be able to replenish and grow. There is a multitude of them released, but only a fraction of them actually become new individuals. My name is Heather Bruck. I am a PhD student at UNC's Institute of Marine Sciences. When stingrays go for buried prey, they'll make these massive feeding pits, and it's a huge indentation in the sand. We don't really know what happens to seeds that were once in that sediment, so that's what my project is trying to uncover. Last summer, I found that there is much fewer seeds within that pit than undisturbed sediment. I'm trying to find the reason for that difference. I believe that it's because the stingrays make almost a suctioning motion when they're creating a feeding pit. When they're doing such an intense, disturbing mechanism, seeds are inadvertently becoming consumed and entering their body. So I'm putting a stingray in a tank. I'll have seeds mixed in with the sediment. I will find food that the stingrays go after and create a feeding pit. And then I'll count the number of seeds after that event has happened. So let's say there's 100 seeds when it starts, but only 50 after this feeding pit is created. To me, that's a sign that there is nowhere else for these seeds to have gone except inside the stingray. I'm also gonna keep the stingrays for a couple of days to see if the seeds are still intact when they pass through the stingray. I don't wanna just leave it at, are the stingrays consuming the seeds? I also wanna see, are they somehow helping with the dispersal process?
Heather and I are both trying to understand what's happening to the seeds. So I'm kind of looking at the landscape level. Maybe there's less seeds in this location compared to this location. I'm Nadya Gutierrez. I'm a PhD student at the UNC Institute of Marine Sciences. I study seagrass fragmentation. Seagrass used to be fairly continuous in this region, and now we're seeing an increase in patchy seagrass meadows. My project is looking at seed bank dynamics. Essentially, the seed bank is just seeds in the sediment. When you go from a continuous meadow to a patchier meadow, you've got increased amount of edges because each patch now has an edge. And it could be that these edges aren't producing quite as many seeds. Maybe they want to fill in the gaps between the seagrass patches. So we could be seeing a lower overall production of seagrass seeds, and that could make it harder for the seagrass to come back the following season. I've got about 250 plots out, and at each plot I've taken these big vegetative cores. I'm looking to see the number of reproductive shoots, the number of different species of seagrass that could be competing, and maybe that's changing the seed production. I'm also looking at below ground biomass. So maybe if they're trying to spread out, they're going to allocate more energy to that than making seeds.
This research will benefit anybody who appreciates or relies on healthy seagrass meadows through understanding what the causes of seed loss may be.
If we lose our seagrass, we could lose our shrimp or our blue crabs or fish that we like to eat. It's really important to understand how these systems are changing so that we can better prepare our fisheries industry, fisheries management, and coastal zone management.